Hi, my name is Ludie Kruger. I'm going to present a short piece on the use of a gate or a noise gate in the music production process. I'm going to use the Cakewalk Music Creator Digital Audio Workstation, or DAW, and what I've done is I've recorded a short piece on playing on a harmonica through really a low quality microphone, and then on top of that I've added some white noise to to really emphasize background noise. White noise, as you know, is noise that is spread linearly across spectrum. So it sounds like this. Although it's not really the focus of this presentation, I just want to make more clear the definition of white noise. White noise is spread evenly over spectrum, but if you look on a linear spectrum scale, you also get pink noise, which is evenly spread, but over a logarithmic frequency scale. Okay, so it is evenly linearly spread. So let's just unsolo this, and looking at the whole mix, we see we have the harmonica channel over here, the white noise that is added here at a certain level, which should make sense in this demonstration, and then this goes to the master and eventually to the wave output. Okay, so to listen to the mix, then we hear this. Okay, so particularly with this piece of music where you have gaps between the notes, not a very flowing piece of music, that white noise in between is very prominent, and that is why the use of a gate makes sense here. So in this case I knew what the level is of the noise because I added it at this level, more or less minus 30 dB, and so that is why if I add a gate, in this case here's the compressor gate in the master mix, it's over here in this console, so attack release is handled on whichever. This is the compressor part, this is the gate part, and I can enable the gate over here, and I choose the threshold to be between the noise level and the signal level, above the noise and below the signal. Now we can listen to it with the noise gate enabled. And you clearly hear that the parts between the notes where you could very prominently hear the white noise, that is now removed by the noise gate. So to summarize then, this is a demonstration of an instance where the noise gate works fairly well, where you have parts that are supposed to be quiet and have a noise associated with it, and you can set a certain threshold and eliminate that noise. The noise gate does not remove the noise overall. In other words, where the harmonica is playing, you will still have the background noise, and there are other ways of eliminating that then. Finally, I just have to say something about the attack and release parameters on the noise gate. These basically control how fast the noise gate reacts. So on a small attack value, the noise will go through that limit for a very short time, and the gate will kick in, and the release is after you leave that limit. In other words, after you are not in that limit anymore, how long is the gate still active? So you can play around with those parameters. I found that in this instance I want a fairly quick response time for the gate.